Hi students, now problem number 2 under the topic motion of blocks on rough surfaces. A 40 kg slab rests on a frictionless surface. A 10 kg block rests on the top of the slab. Okay. The coefficient of static friction between the block and the slab. So between the 10 kg block and the slab, the static friction is 0.6 and the coefficient of kinetic friction is 0.4. A force of 100 Newton acts on the 10 kg block. Find the resulting acceleration of the slab. Okay. So it's a very interesting numerical problem repeatedly asked in competitive exams many times before. Now first of all let us take the mass of the block is M1. So M1 is equal to 10 kg and M2 is equal to 40 kg. This is the slab. Now the coefficient of static friction is given as 0.6 and the coefficient of kinetic friction is given as 0.4. Okay. The applied force is equal to 100 Newton. So what is the acceleration of the slab we have to find out. Now first of all children, the static friction coefficient and kinetic friction coefficient of the mass 10 kg block is given, isn't it? So first we will find out the limiting friction, which is also called as the static friction. This is the limiting friction. The static friction on M1, okay, is taken to be F1. So this is F1 static, is it not? F1 static. So this is equal to mu static into mass M1 into G. So this is mu static is 0.6. Okay. So multiplied by the mass is 10 kg into G, I will take it as 9.8. Unless they give the value as 10, we are supposed to assume the value 9.8 only. Okay. So this is 0.6 into 10 is 6. 6 into 9.8. So this is equal to 58.8 Newton. So this is the static friction. So 58.8 Newton is less than 100, is it not? So 58.8 Newton is less than 100 Newton. Applied force is greater than the static friction. Therefore, the mass M1 will move towards the left. Therefore, mass M1 will move towards the left. Okay, now when the body has started to move, another friction called kinetic friction will come into the picture, isn't it? So, kinetic friction on the block A. So, kinetic friction on the mass M1 is taken as F1 kinetic. So this is equal to mu kinetic into mass M1 into G. So this is given as 0.4. So coefficient of kinetic friction 0.4 into mass is 10. So into G is 9.8. So it is 4 into 9.8 and this is found to be 39.2 Newton. So this is acting in a direction here. This is 39.2. So this is F1K is equal to 39.2 Newton. So it is opposing force. Kinetic friction is opposing the applied force. So what is the net force acting on this is 100 minus 39.2. This is acting on the mass 10 kg. Now, the same force as a reaction force. This is acting on the right hand side, is it not? This is acting on the right side of the mass M1. And also, it will be equal to the kinetic friction acting on the second mass also. So, this is equal to F2K, because this is the only force acting on the slab of 40 kg mass. So F2K I am representing, that is equal to F1K, that is equal to 39.2 is acting along the left hand side. Okay, therefore F2K, so this is also equal to F1K, and this is equal to 39.2, that is 40 into, so this is equal to 40 into acceleration of the slab, m into a. Understand that? So F1K 39.2, so 39.2 is equal to 40 into a. So using calculator we can find out this. Therefore a is equal to 39.2 divided by 40. So this will be equal to 0.98. Therefore acceleration of the slab, therefore for the slab the acceleration is found to be 0.98 meters per second square. So first of all we have to find the coefficient of friction. From that the force of friction acting on the mass m1. The same force as a reaction force, it is acting in the opposite direction on the mass m2. There is no other force directly acting on the slab except this force. So this force must be equal to mass of the slab into acceleration. So from that we have found that acceleration is 0.98 meters per second square. I hope you must have understood well. Fine.